Suppose I have a curved surface, literally a surface here in 26,100, which sort of looks like this. Something like this. I call this arbitrarily y equals 0, and I could call this u gravitational potential energy 0 for that matter. So this is a function y as a function of x, and the curve itself represents effectively the gravitational potential energy. This is y, and this is x. So the gravitational potential energy u equals mg y, but y is a function of x, so that is also u times m, that is m times g times that function of x. There are points here where du dx equals 0. I'll get a nice mg in here. Where it's 0. And where are those points? Those points are here, 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 and here. If the u dx is 0, it means that the force, the component of the force in the x direction is 0, because the u dx is minus the force in the x direction. So if we visit those points, for instance here, then there is of course gravity, mg, if there's an object there, in the y direction, in the minus y direction, and there is a normal force in the plus y direction, and these two exactly cancel each other. So the net result is that here, 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 and there is no force on the object at all, so the object is not going to move, it's going to stay put. Well, yes, it's going to stay put. However, there is a huge difference between this point here and that point there. And you sense immediately that difference. If I put a marble here, I will have a hell of a time to keep the marble in place. Because if there is a fly there in the corner of 26,100 which does something, then the slightest amount of force on this one and it will start to roll off. In fact, what will happen is it will go to a lower potential energy. Here, however, if this one is offset, then it will want to go to a lower potential energy. The force is always opposing the direction of increasing potential energy, so the force will drive it back, and so that's why we call this a stable equilibrium. It will always go back to that point, and this is an unstable equilibrium.